In the future, advanced dexterous bionic arms are a common feature on most robots. These worker bots perform complex and delicate tasks in environments too hazardous for humans. From hundreds of miles away, skilled operators remotely perform nuclear cleanups, fight fires, and even repair the space station from the safety of Earth.
Mechanically enhanced humans have long been popular in sci-fi stories and superhero comics. As a partial machine myself, I'm excited by the real superpowers that our cyborg future will bring. But in everyday life, making cyborg technology work seamlessly with the human body is hard. When it comes to enhancing the human body with technology, balance is essential. Weight, speed, strength, these are all factors that must be considered when designing and engineering wearable robots. At Exobionics, Jason Jones is taking on the daunting challenge of bringing man and machine into sync.
Our main purpose is to enhance human capability through robotics primarily, right? So either for medical purposes or for industrial.
They've developed several true-to-life exoskeletons.
In my lifetime, I think you'll see more of people being augmented by machines. The approach we're taking is, instead of replacing people, let's make it so they can do more. If they want to, they can work into older age because they have enhancement.
Jason's colleague, Zach Haas, shows me exactly how their exoskeletons boost worker productivity. This model is already being used in factories.
See how it feels?
I feel like I'm supposed to be really, really strong now.
Right.
Now that I have this on.
This is designed to really give sort of superhuman endurance.
Okay.
Yes.
I'll take that.
There you go. So now as you go to raise your arms, you'll feel it kick in, yeah.
Oh, okay. Yep.
Feel it?
Yep. And then,
What's it feel like?
like my arms are like free floating.
There you go. That's the key word there.
This free-floating sensation happens with mechanical spring-driven technology, which reduces strain on the arms from repetitive motion. It's so wild. I can absolutely feel the power and how it would transform industry. But for some, it might be intimidating.
Do you think there's a little bit of fear in the idea of like presenting some of these technologies?
Yeah, a little bit of sort of, there's just this idea. What is this a robot? Am I a robot now? Am I working with a robot? What does that mean? It's a machine that we're now strapping to your body.
Right.
And it's got to work with you and you've got to work with it.
A little bit more personal.
A little bit more personal. So yeah, there's definitely more sense of trepidation there. But once people see the benefits, a lot of that disappears pretty quickly.
Look, Ma, I'm a robot.
Not only do exoskeletons boost human productivity, they can also restore locomotion to those who've lost it.
I'm gonna get to meet somebody who uses one of these exoskeletons and has this whole interface with technology like I do.
At the age of 32, Jess McNair experienced multiple strokes and lost the ability to walk.
It affected the right side of my body. It also affected my balance and vision pretty severely. It's been a journey.
With the help of physical therapist Jen Masievich, this exoskeleton is changing Jess's future.
1, 2, 3, push.
So cool. Can you explain to me what is actually allowing you to do things?
There's basically 4 motors. There's motors at the hips, and then at the knees. And the ankle doesn't have a motor, but it actually allows us to position her for greater balance.
That's really cool.
So it allows someone to be fully weight-bearing, but also supported in a frame in a proper biomechanical position. All right, Jess, do you want to start the first step with the interface over there?
That's so cool.
An onboard computer uses feedback from sensors in the exoskeleton, and sophisticated algorithms process that feedback and then apply the proper amount of movement to each biomechanical joint. This coordination of man and machine represents a tremendous breakthrough. The exoskeleton is teaching Jess how to improve her gait.
We want them to be able to walk again. We want them to be able to step out of the device with a better walking pattern.
What do you hope to see in your lifetime?
The goal is to make it smaller, lighter, more adapted to the human body and less apparent.
So you want it to be like more of a part of you then?
Exactly, yeah, more bionic.
Exoskeletons like these have humble origins. Early versions of this technology were clunky at best and seem laughable to me today.
One may witness a scientific endeavor to convert a man's legs into those of a giant.
But every evolutionary path must start somewhere, and our cyborg future is advancing fast. The team at Exo would know. They've also developed exoskeletons to assist with punishing physical outdoor tasks.
Carrying large, heavy loads over long distances or increasing endurance, that kind of thing.
These powered exoskeletons can help a person carry a 200-pound pack swiftly across rugged terrain. Incredibly, the wearer would only feel a mere fraction of that heavy weight.
These here are hydraulic cylinders, and they basically are kind of like a parallel muscle with your quads. So you can press down harder if you're walking up a hill, for example. It'll give you a little amplification. The design attempts to amplify your force, right? So if you're applying a certain amount of force, and it would add to that to kind of offset the effort that you're putting into it.
That's really cool.
In the back, you know, there's electronics in here, and there's a hydraulic pump and control systems.
And then we talk about mud and rain, obviously the electronics.
Yeah, the challenges they're pretty big challenges in military.
I have those challenges myself, so. Yeah.
Future versions of this cutting-edge technology will someday be widespread.
I think in the future, you'll see many people wearing assistive devices on a daily basis. I'm almost certain that those devices will be controlled at some level through interaction with the human's nervous system or their brain.
By enhancing our bodies with advanced robotic exoskeletons, we're taking a step closer to the cyborg revolution.
In the future, miniaturized, power-boosting exoskeletons are integrated into custom garments. With the press of a button, superhuman strength and endurance is available to everyone. This body augmentation reverses the decline of old age, restoring youthful vigor to anyone who still has a passion to work or explore.
In our cyborg future, wearable machines will augment our physical selves, and wearable computers will augment our minds with instant access to worlds of information.
I would wear wearables, yeah.
How will advanced wearable computers impact the way that people work, learn, and interact with their world? To find out, I've come to Atlanta to meet a true pioneer in wearable computing, Thad Starner.
For me, the real killer application for these wearable computers is augmented memory. Machines that become part of your mind, give faster access to knowledge, make you stronger in the sense that you have all this information you can use to help you on your day-to-day life.
So this was the first thing you worked on at MIT?
Right. Most people had no idea why you'd want a mobile computer because laptops weren't even out there yet.
While attending MIT, he became frustrated by his inability to retain what he'd learned in class. So Thad built this augmented memory system to take better notes.
You ready?
Oh, I'm gonna put it on.
So bring your fingers around like this. There we go. So now that is my daily suit in year 2000. So you have this plus a car phone plus a 7-pound lead-acid battery.
Do I look really stylish?
Actually, it looks pretty good on you, to tell you the truth. Yeah.
Though retro now, Thad's system had a portable computer, typing device, and a heads-up video display over one eye.
I found that once I had the ability to take notes in class, and especially this portable system, I took notes in person-to-person conversations. And that's one thing computers are horrible at right now, is assisting you during this sort of interaction.
Right.
But having a head-up display, you only use it when you need it, and it keeps your eyes in the world around you. And I find it to be really a good augmentation of the conversation.
The heads-up display overlays information within the user's field of vision. The system can be used to access applications or the internet. It can also augment your surroundings with information that only you can see. That eventually led a team that turned this tech into a commercial product. Google Glass.
That's the first functional one. We had to glue a cell phone to the side of our head to get a trackpad that worked.
That's wild.
Advanced smart glasses like these are making workers more productive in industries like manufacturing and healthcare. And it's easy to see why. By beaming information directly into the eye, the wearer can work on complex tasks, all while absorbing crucial information hands-free.
It's actually lasers in the side here that's bouncing off. If you get it just right, you can actually see a little mirror here. It's kind of hard to see.
Oh,
but
yeah.
You just get it? Yeah.
Yep.
And so it bounces off the lens and back into your eye.
That's so cool.
Breakthrough technology like this is getting smaller every year. Even now, it's being developed for contact lenses. The Mojo lens is less bulky than smart glasses and completely invisible to others. When paired with a smartphone, they not only display information for the wearer, but also improve eyesight.